Welcome back. We're in lesson 21. We're going to talk about scientific notation first. As a refresher, we know that when we have a number, let's use this one right here, and we have it in scientific notation format with a positive exponent, we know that when we do this math here, that it's literally saying 10 times 10, right? So that's going to be 100. So this number times 100, that's what we're looking at. And we know 100 has two zeros, so 1, 2. The benefit of using the decimal system with a base 10 that we use is because we have this special advantage that when we multiply a number by the power of 10, the sole effect is that it just moves the decimal point however many places it's listed here. So we can just rewrite this number here and move the decimal point 2 spots, and that's our answer. Same thing, we use this number again. We can change the value by just changing the exponent. So we write it again, and then we count decimal places, 1, 2, 3, and then we add a 0 for the fourth one. So we add a 0, and now we put in our commas, and we have 4,120,360. So this has the value of however many places we want to move the decimal. Now notice, when we have a positive exponent, the number we multiply it by is going to get bigger. Positive typically means the number is bigger. And if we have a negative number, let's say 10 to the negative 2 this time, negative means that something's going to get smaller. So when we write these numbers again, it's going to get smaller. So it's going to move to the left. So we put our decimal place here. So you can see how the positive or negative symbol affects what we have here, our constant that we're multiplying in scientific notation. Again, if we had 412.036 and we had 10 to the negative 4, we would write our number and give ourselves a little room because we know what's coming. We're going to have to add some zeros on this side. So 1, 2, 3, 4, we have to add a 0 in front, put the decimal place, and usually we put a 0 in front of that as well. So you can see how the number affects the spaces, but the positive or negative sign affects which direction we move the decimal. So positive goes to the right and negative goes to the left. That's very important. This illustration will give you everything you need to remember which way the decimal moves when we're doing scientific notation. All right, so I'm going to clear this page because we have a problem that's kind of large that we need to look at. So our problem is 21.1, and it is 0.000. I'm going to try not to say this and just let you guys copy. I have a bad habit of saying the number as I write it down. I'm trying not to do that this time, so you guys can copy that problem. All right. So I'm going to allow you the opportunity to solve this on your own to see how much you remember. So pause the video and try to work this on your own and see what you have, and press play when you get it solved and come back and see how you did. All right, so let's walk through this. I thought about putting the answer up here first, but I think that we need to walk through it. You should have simplified the top by saying, okay, I need to make this a constant. So 1, 2, 3, 4. and I'm moving this to the right, so when I multiply, this number is going to have to get smaller. So that means a negative number here. So 3 times, and that was 1, 2, 3, 4 places, so that's negative 4. So negative 6 and negative 4 is negative 10. Now we're going to do the same thing here so that we have a simplified number. So we're going to say 4, and we move it 1, 2, 3 decimal places. And it's a positive 3 because when we multiply this times this number needs to get bigger. So positive means bigger. Right? Right. Okay, then you would take the bottom and do the same thing. We know we have 6 times 10, but 6 times 10 to the what? So again, 1, 2, 3, we're going to make this number, when we multiply, it's got to get smaller. So it's going to be a negative 3 because negative 3 is, negative is smaller. So negative 3 and a positive 15 is going to be a positive 12. We just put them together, just like regular math. 15 minus 3 is 12. Same thing here. We know it's going to be 2 times 10 to the something. Well, if we move the decimal place 1, 2, 3 places, we know when we multiply this has to get bigger. So it's going to be a positive 3 because positive is bigger. So 4 plus 3 is going to be 7. Then we just have to multiply our constants and our scientific notation. So 4 times 3 equals 12, right? And now we just treat these like variables, right? So times 10, and they're the same variable, times 10 on both. So now we just look at the exponents. We have a negative 10 and a positive 3. Together, that's a negative 7. We just combine them. Same thing here. Multiply our constants. That's 6 times 2 is 12. We know it's times 10 because that is our variable, our scientific base. And we just combine our exponents. 12 plus 7 is 19. Now, if you got here and stopped, that's on the right track, but you're not done. You have to divide. 12 over 12 is 1. We know we bring down the times 10. And if you remember, whenever we are resolving this, we treat it just like a variable. We always treat it just like a variable, and we would bring it to the top and switch the sign. That eliminates that on the bottom. And then because it's a variable, we treat it just like we did here. Times 10 times 10. We combine the exponents. So that's going to be a negative 26. That is the answer you should have finally gotten to. Now when you walk through the steps like this, you can see how easy it is. You just want to make a constant. You want to make a whole number that's a lot easier to deal with. I mean, I really don't want to have to multiply 4,000 times this. I really don't. And when both of these numbers, both of these expressions have the same variable, regardless of their exponent, when they have that same base times 10 with an you treat it just like a variable, and it's so much easier when they're both the same, because then you don't have to do a lot of math and a lot of multiplication and decimals, and you can get that all out of the way. So this is your result. So keep in mind the steps: simplify, multiply, combine your exponents, and divide. And when you divide these exponents here, these variables, you just flip it up and combine the exponent here, and then write that down there. That's all you do. Very simple. All right, let's move on to statements of equality. These are more of those ratio word problems, only this time it doesn't have something that you can visualize. It's just talking about numbers. So I'm going to clear the page. And the first one is 21.2. And it says you have a ratio of two numbers that are 3 to 4. All right, they're just two numbers. We don't know what they are. We'll call them X and Y, right? And their sum is 84. Okay? So what are the numbers? So we know that X plus Y equals 84. That's a given, so we can say that x plus y equals 84. And we know that they have a ratio of 3 to 4. Remember, when we're dealing with ratios, that we want to add them together so that we can make a fraction. So 3 is out of 7. The total amount here of the ratio is 7. So 3 out of 7 is equal to some number out of 84. So all we have to do now is cross multiply. And 3 times 84 is 252. And then you have 7 times x. We divide both sides by 7. And we get 36 is equal to x. Easy peasy. So if 36 is equal to x, we can sub in up here 36 plus y equals 84, right? Subtract 36 from 84, y is 48. So now we have both numbers. Easy peasy. Okay, so that's a way to do it with ratios. So let's do 21.3. I'm going to clear this. And with this one, we're told that the sum of two numbers, so x plus y, is 128. And we are told that their difference is 44. What are the numbers? Okay, so we have x plus y is 128. Now we have x minus y is 44. That looks like an elimination problem to me. Does that not look like an elimination problem to you? We have a positive 1y and a negative 1y. We can just eliminate that. And we have 2x is equal to, sorry, excuse me. 2x is equal, and those are both positive, to 172. I had to clear my throat there. Sorry about that. I'm still getting over this cold. So now we just divide both sides by 2, so x equals 86. All right, so now we can just sub in 86 up here. X plus y is 128, so 86 plus y is 128. So when we subtract 86 from 128, y is equal to 42. So now we have both numbers. Easy peasy. Now the way to check that and make sure is to sub these numbers in for the second fact that we're given, which is that their difference is 44. So if we sub in x as 86 minus y, which is 42, is their difference 44? Yes, so that's correct. So we know we found the right numbers. And that is all we have for lesson 21. Think about how things are worded. Think about how you can write them as a number problem. And then look for ways to solve them. When you have that ratio, you know you can use cross multiplication. When you have something that looks like elimination, use elimination. If it were to look more like substitution, use substitution. But you can use any of those three methods to solve these word problems that have to do with ratios and numbers or subscripted variables. All right, and that's all I have for lesson 21, and I'll see you in lesson 22.